one when it comes to storage, compute, backup, appliances, building the end-to-end data center solutions for various different customers across the geographies. So I've just taken um, data center as a use case here, or rather on premises. So when you take data center, I think there are a lot of alerts, syslogs or traps that are coming up from various different devices, servers, applications, so on and so forth, right? So what we do is we kind of collect all those alerts and informations and kind of dump them into storage boxes. Like it can be any file share, or it can any be something like a block storage as well, doesn't matter. So we will kind of dump all those data elements into the data sources. And once the data is been collected, what we do is we kind of parse them. I mean, typically we are going to understand the data, we are going to split the data. And once the data is been converted, we are going to move them into chunks. And those chunks, or rather embeddings, will be stored into the vector DB. Right? This is typically like a DB where the embeddings will be stored so that any LLM can access this vector store and start pulling out the embeddings that is required to kind of answer your query that is coming from the chat interface. So once these embeddings are being created and stored in a vector store, nothing but kind of a database, what we do is this particular layer will be connected to the LLM. There are a lot of LLMs that are available in the market. I'm just taking Llama 2, which is again the open source LLM, right? So what we do is for this particular layer, we are connecting Llama 2 engine so that it can have the interface to the web front end, which is nothing but the chat UI. I think we all know the chat UI. It will give us the option to kind of receive the input from the end user. Typically, nothing but the query will be received, or rather, the prompt will be received by the front end. And it would connect back to the LLM saying that, hey, the user is actually kind of looking for a response for this particular query. And the work of LLM is to go and kind of talk to the vector DB and fetch that response back, right? So we can do a lot of response enrichment if at all, if it is required. Else, it will send the output back to the end user. During this particular process, we will also try to kind of build a feedback loop so that we can kind of understand how good the LLMs are responding to the end users queries. I mean, do we need to kind of update the or rather look into the data sets that we are kind of connecting to the LLM? Any changes needs to be done, or even monitoring the GPU resources, right? So those things will be kind of performed under monitoring, reporting, and kind of building that feedback loop. So this is a high level architecture. So what we will do next is kind of get into a demo. I'll quickly walk you through few pieces of code and understand how this particular UI can be launched, and we can kind of chat with the chat engine. Hope you're able to see the studio code.
Yes, we can see this
Yeah,
VS Code.
yeah, cool. So there are 3 to 4 steps that are quite required while we build this chat engine. The first thing what I'm going to do is I'm going to load the CSV file. And the CSV file, the data that I kind of load that into this code, what we do is we are going to do the I would say something like splitting the text, right? So to split the text, there are a couple of functions that I have developed in this particular code. And once the text is being split across various different chunks, we are going to move those chunks into an embedding format. So what we do is to move that into an embeddings. We are actually integrating with Hugging Face as one of the integrations so that I can convert this the entire CSV into embeddings. And once the embeddings are created, I'm actually storing them in one of the vector DB here. With respect to the vector stores, I'm using Facebook AI similarity search as one of the vector stores. and the entire the orchestration of this particular activity will be happening with LangChain. LangChain is more like an orchestration engine, which will help me to kind of do all these activities. And for the web application, I'm using Streamlit as one of the library to build the web application with a much faster. That's easier way at least to build the web applications for the um, chat interface. Trying to do something locally within the lab, I think you can kind of depend on Streamlit, and that will help us to kind of build the UI much faster. Same thing, I think I've created those functions. We can see that I'm uploading the CSV data, and once the data has been uploaded, we are calling Hugging Face integration to create those embeddings. And I'm using the sentence transformers to convert this. And once the embeddings are created, I'm storing them into the DB, nothing but Facebook AI similarity search. And I'm loading the Llama 2, the entire LLM here, so that we can kind of build that end-to-end engine, which can be driven with LangChain here, right? So this is how the chaining activity is happening, and I'm using the Streamlit library to build the web interface. So let's launch the web interface. I'm also using Anaconda Navigator just to kind of launch some of these components. And the best part of this code is that you can flip the engine either for CPU or even CUDA. Let me show you the NVIDIA GPUs that are available here. So I have the NVIDIA GPU in my laptop, and what happens is I can flip the entire code to execute either on a typical CPU or on GPU as well. So that's the benefit of kind of mapping the device here. So I can actually select NVIDIA, or I can even execute this entire code on the CPU as well. So it doesn't matter. It shouldn't take much time, even though if you're using CPU as well. But there is little latency compared to the GPU, but still the things works, right? So that's the one part. And this is the web interface. And what we will do is we'll upload some CSV data. I'm just taking one of the sample CSV data. This can be anything. It can be for any databases, right? I mean, if you have any standard operating procedures in your operations team, it can be any web application logs, or any process procedures, or any documents that you have downloaded from SharePoint, for an example, right? So some of such proprietary data can be uploaded to the chat interface. And the moment when you upload, you can see that it's running. I mean, it is trying to understand this incoming data, and the sentence transformer library will be picked up. It would convert them into embeddings, and it would store them into the local DB, right? Nothing but the vector store. So let's wait for a couple of seconds so that I'll get the prompt response once this uploaded data is being digested by the LLM, the large language model. Yeah. So as I just mentioned, I have taken PowerMax as one of the sample hardware. PowerMax is nothing but the data center storage, which is one of our leading products from Dell EMC. So I've just taken the PowerMax as one of the hardware within the data center as an example here. And the data that I have loaded is nothing but all the errors, the error information, error code relevant to this particular hardware, so that any operations guys working 24/7 can pick up a sample error, and it can, I mean, they can actually have a chat with this particular UI and get some more details what needs to be done with respect to that particular error or the alert. So let's get into this particular CSV. We'll pick one of the sample error and we will see how the responses would be coming from this particular chat engine. So let's pick one of the error. So it would be an error called not all valid, nothing but all the disk pairs are not in the mirrored valid state, right? So that's one part and the error code is 14 here. So let's see if it can start responding if I need to get more details on this particular error. So any query that you are passing it on from this chat interface, it would again go back and it would validate and again look for that vector store and provide the response back. So that's one part. And the another thing is if it is not part of the proprietary data that we have uploaded, then again it would go for, I mean, that is what it depends on the Llama 2 and it would use that LLM and fetch the relevant information as well. Yeah, since I'm using CPU as kind of a backend processing element, it might take a couple of seconds. So far, any questions? Should I need to flip it to the questions board? Is this code is on the GitHub? No, it's not in the GitHub, but I can kind of upload it to GitHub and share this back. How many of those services are containerized? I think the entire code can be containerized like a Docker container, and we can even run this on Kubernetes, right? Do you see specific software like LangChain? Yeah, we are using both LangChain and Streamlit. And what is an SOP? SOP is nothing but standard operating procedures. Typically, if the data center teams need to understand what is the error, what should I need to do? Should I need to create a ticket? Should I need to pass it on to a specific team, right? So that's process is called the entire standard operating procedures. It will be documented like a run book so that the data center experts can kind of look into that SOP and act accordingly. Again, if you see this particular CSV, I didn't have anything around the product itself, right? However, though it was a generic query, what is this Power Max storage is all about? It went back to the LLM and it was able to fetch the details for this Power Max as the product, right? So it is giving me the information. So now let's pick one of the error from this Excel and we will try to validate. So I've given another query. Let's see whether it can bring the relevant response. If it is not bringing the relevant response, so that's the reason why we have the feedback loop so that we can kind of understand what queries and why it is not able to kind of respond according to the required query, because we are storing the chat conversation history as well. And that will help us to kind of identify these anomalies and kind of build that particular engine so that based on the user's query, we would get the response accordingly. So now you can see that it's running. So it's going back and kind of doing the vector search and it is going to pull that relevant embedding according to my query. And if at all, if it needs to have any enrichment to my response, it will be doing behind the scenes. And finally, it would give the response back to the chat interface. I'll flip the gears to the questions. What laptop model? Okay, I'm using Dell Precision Dell Precision as the NVIDIA GPU. I have 64 gigs NVIDIA GPU in my laptop, and I have another 64 gigs for the typical Intel CPU. So yeah, I can kind of use CPU or GPU.
And Raghavendra, we also have one more follow-up question in the Q&A in the chat,
Okay.
which is from Harold about your Streamlit and LangChain. Can you
Mhm.
show us on your architecture model where each of Streamlit, LangChain, and Hugging Face are placed?
Certainly. So yeah, based on my query, it came back with the response, right? Not all valid, which means that the storage drives are not valid. I mean, typically, if you look into this particular response, right, there is a state in the sense it should be valid. I mean, the drives should be valid enough for us to dump the data, and if it is all not valid, and that is one of the error context, and it is able to kind of go back to this particular proprietary data that I was able to upload, and it is fetching that information, right? So that's the benefit where it goes and it looks into the proprietary data, and this particular process is called RAG, right? You are uploading the data, you are making the LLM to understand your business domain knowledge, or rather the proprietary data, and you're ensuring your chatbot engine would use this proprietary data to provide the much accurate responses to the end users. So this is what kind of a process, or rather a demo, that I wanted to show. But going back to the questions on the Streamlit LangChain, yeah. Uh, See here, I think this is where I was telling the LangChain is the kind of an orchestration engine, right? So what we do is I'm actually using LangChain itself as the main library, and I will be getting all these methods from the LangChain, like loading the document, embeddings, vector store, so on and so forth, right? Because that would help me a sequence of activities that can be executed, because it can be treated as a orchestration engine. And I have Streamlit. Streamlit is typically for the web application development. So here you are seeing Streamlit, right? So it's more like HTML or CSS way of developing the UI. So I'm just calling those relevant functions. And I mean, if you see, there is dot file uploader. So this is all the utilities that are available, functions that are available, that you can kind of use this Streamlit to build the web application here, right? And I'm just doing some if else conditions, because if the, I mean, you can even set the size of that particular file as well, right? If somebody is trying to upload 10 gigs, then you can kind of minimize the size of that particular validation as well from the file size perspective. So those additional functions can be developed and can be embedded here. So take Streamlit for the web application, or the chat UI development here, I mean to say, and you can kind of give all these methods to make the UI much richer. You can even add any logos if at all, if it is required. You can even further go ahead and build logout or login kind of a functionality. And the entire activities are happening via LangChain here, right? So this is a simple explanation about the code. Any other questions?
Thank you so much, Raghavendra. We have few more questions on the Q&A session in the Slido. If you want, I can go through that. Yep.
Yeah, because I'm using CPU as the inference activity, yes. Because again, right, the moment when we move this particular chat engines to the data center level, typically when you have like NVIDIA SuperPod or machines with GPUs, the responses will be much faster. So that's also another activity that we do, is to kind of see what is the latency. I mean, when I'm trying to use multiple LLMs, another activity that we do for our customers is to validate the latency, validate the performance as well, right? We do a lot of LLM benchmark testing, and we will kind of understand what the results would be or the performance would be when concurrent users are trying to consume these capabilities. So there is a lot of testing that happens, and since it's a the reason why I've picked up laptop and that too with a GPU or rather CPU is that nothing is stopping you as a developer to use the CPU, right? Because there might be a narrative that without GPU I cannot do anything on the generative AI. So that's not the case. With CPU, you can still kind of write simple code and kind of connect your data, kind of try to play around with the chat interface, right? So that's the whole overall idea here. What changes are needed to run this code on Google Cloud Platform? No, I don't think so. You need to change much. Even a simple Linux machine on Google Cloud GCP platform should be good enough to run it on the GCP, right? Just spin up a machine and you should be able to play around with this code. Else, um, you need to write a Docker file and convert this into a Docker container. And you can even use the containerization as well. Just to clarify, Streamlit for web frontend, LangChain for orchestration. Yes, Streamlit is just for the web frontend. Yeah, that would, because Streamlit is having a lot of libraries that will help us to speeden up development process for the UI, and LangChain understands the incoming data based on my query. It will go back to the vector DB, fetches that embedding and provide me the response. So that entire chain of doing the things is what done by LangChain. Yeah, where you have plugged in the language model. Good question. I'm using Llama 2 here. Let me show you the file structure here. So the code, I mean, the data that I have uploaded, it's actually changed into the chunks, and it's already stored into the local vector DB. So here I have a local DB, nothing but a vector store. And the logic of this entire chat engine is developed in app.py. And I have already loaded Llama 2, the LLM here, and I'm calling that particular model, the LLM model. That would be the first function itself, load LLM, and I'm kind of loading this and passing it on in the underneath uh, functions based on my requirement here. So yeah, in the interest of time, I don't see further questions.
Yeah, we can take the last. Okay, we already took the last question, right? Okay, perfect.
I think, yeah,
We have one more.
another
Yeah.
one popped in. Yeah, what changes might be needed if you are using a graph database? I think you can use GraphDB. Neo4j, even have used Neo4j if you want to kind of understand the dependency of the data, right? So GraphDB is also good, right? That's a good question. I mean, if you assume if you need to understand how the data is connected to like other data elements, right? Assume to make it in a much simpler way, if your virtual machine is connected to the physical machine and having the connections to storage network, something as such, right? That entire topology can be visualized in your 4J DB or a graph DB, I would say, right? So that would kind of help you to understand how your data attributes are and how the data is being widespread, and you can kind of understand the other domains of the data where you need to be a little careful while you try to do a lot of data transformation activities. Yeah, I'll work with Darshan and pass some slides and the code as well. I mean, if you want to kind of run this out in your local laptop with a CPU as well, certainly. So that being said, I kind of answered all the questions. I'll stop sharing the screen.
That's great. Thank you so much, Raghavendra, for sharing all the knowledge. Yeah, Harold also wanted to see the architecture diagram, but yeah, since you are going to share the slides and the project, uh,
Mhm.
yeah, I guess
Yeah,
we should be fine with that.
yeah, yeah.
Okay,
So
thank you
last
so
question
much.
is there from Harold that what vector databases have you tried with? Yeah, you can use Pinecone. Pinecone again is a SaaS based, but you can. I've tried ChromaDB, PG vector as well. But apart from the FIAS that I'm using, you can use ChromaDB. That's also another good the vector store to store your embeddings. Yeah, thank you. Go ahead, Darshan. Thank you.
Yeah, thanks a lot, Raghavendra, for answering all the questions. Uh, so for the next session, we have ChengCheng. Uh, she's joining from California. ChengCheng is the owner of Cheng to Design, and she is also a senior communications specialist at Far AI, where she focuses on using the LLP models in AI safety. She is also a Women Tech Makers ambassador, and she is committed to supporting women in tech. So today she is going to talk more about the NLP and the recommendation systems on GCP. Over to you, Cheng Cheng.
Thank you. Let me get my screen set up here. Everyone can see okay? Yes?
Yep.
Okay, so hello, and thank you for the lovely introduction and welcome. Thank you everyone for joining for another session of Road to Google Developer Certification. So as Darshan mentioned, I'm ChengCheng. I originally studied linguistics and computer science, then went on to get my master's in CS, and I currently work with large language models in AI safety. Most people have no idea what the heck that means. So I do help. So Far AI is a technical AI safety research lab based in Berkeley. So I communicate their findings to other ML researchers. I also help with an AI safety education website, building their chatbot, very similar, using RAG, retrieval augmented generation, that you just heard about. So the answers are grounded on all the literature from the AI technical safety research that's constantly getting published and updated. So it's not so much it's private information, but it's because the information gets updated, and so we need to keep up with the latest and greatest research. So where are we? We're on week 5. The topic for your courses and labs this week is NLP and recommendation systems. So between ChatGPT and the Gemini buzz, I'm going to take a slight detour and start with an overview of LLMs and NLP. And since you're going to have a Build with AI event next month, I'll also give you sort of a quick preview on how to use that Gemini API so you can start playing with stuff and brainstorming some ideas. And then we'll actually review the core content for week 5, which is focused mostly on the TFX framework for deployment, and wrap up with some Q&A. Okay. So by now, you've probably know that LLMs are large language models, but what are language models and how do they get so large? And so language models, they're part of NLP, or natural language processing. That's what I originally studied in college, back as a computational linguist, but things have completely changed since then. The holy grail of NLP is to be able to talk with computers, just like talking with other people, right? So no need to learn all that unnatural computer languages. So if you went through the NLP course, what I present is kind of similar in content, but maybe presented in a different way. So hopefully my hope is to give you sort of a sense on how everything kind of fits together. So way back when I first got started, decades ago, linguists would create these expert systems, like hand coding zillions of these grammar rules and all the vocabulary. Super tedious work, and the results were kind of mediocre at best. And when they started off using more, then they started using more statistical models. So how would that work? So if you've heard of things like bigrams or trigrams or n-grams, that's kind of what we're talking about here. So there's a quote that says, "You shall know a word by the company it keeps." So this was actually a simple idea that was very profound, that if you start counting words or groups of words, bigrams are pairs of words, trigrams are pairs, 3 groups of words, or n-grams. So if you just start counting them and just looking at what other groupings are around it, you end up learning a ton about the language. And so those relationships actually end up making a language model. So if you think about learning languages as children, right, you're kind of immersed with all these sounds and sentences, and you end up just knowing what feels right or wrong, even if you don't really know why. So you've internalized the statistics of your own language model. Okay, so neural networks, they've been around for decades, but they didn't really take off until maybe around the last decade or so. So you've probably heard before the ChatGPT craze, computer vision was really the big deal. But language models have actually been quietly making progress all along. And Word2Vec was a Google invention using these high dimensional vector embeddings. We kept on hearing a lot of that in the RAG there. So you can kind of just think of them as a long list of numbers, right? So neural networks had just learned a bunch of these numbers or vectors that could represent the meaning and relationship of words. Then you can start doing vector arithmetic, like if you have the vector for king and queen, the difference there gives you the gender relationship. Then you can add in the vector for woman to your relationship, and you'll end up getting a vector for man. So that's pretty cool. And so just by looking through tons and tons of text, that's called a corpus, the model could end up solving like all of these analogies on its own. So there's no more need for all that tedious hand coding stuff. So this was a total game changer, right? And we'll see later on that vector embeddings aren't just for representing words. We use them for representing sentences and paragraphs, and then you can even use them for images, video, and audio. And then if you saw users and products can be represented for recommendation systems. So it's very powerful stuff. So other neural networks around this time included RNNs, GRUs, LSTMs. So these were actually early generative AI, so they could translate, write stories or recipes. So I mean, they weren't great, but they not horrible. So they were decent. So those early models, I mean, they were kind of slow and forgetful. It's kind of like this.
I think we lost ChengCheng, or that's only me. Okay, we'll just give her a moment to rejoin again. Okay, I'm just waiting for ChengCheng to join this call so that I can make her a presenter again so that she can continue where she was stuck. Okay, I guess while we are waiting for her to join, uh, Raghavendra, if you are still around, uh, there was a question from Harold about the architecture diagram. He wanted to understand,
Mhm.
uh, yeah, where the Streamlit and Hugging Face are placed. So would you mind sharing while we wait for ChengCheng?
Yeah, why not?
Okay, so we have ChengCheng on the call. Yeah, please go ahead, Raghavendra.
Yeah, I'll just take 1 minute to answer that question. Um,
Yeah, no worries. Thank you.
yeah, the Streamlit will be part of the web front end. Streamlit will be this particular layer, right? Again, right? It's not that you have to use Streamlit. You can even use a simple HTML based web application as well. However, it has to kind of connect to the LLM. LLM will be here. The Llama 2 that we were talking about will be part of this particular box. And the data that I have uploaded will be part of the first process where we are uploading the data, creating those chunks and embeddings and storing them into the vector store, right? So this is your Streamlit, this is your Llama 2 LLM and the proprietary data. So this is the architecture that we were kind of discussing. And I have kept quite simple in nature in the sense not specifically telling that it has to be Streamlit or Llama 2. The architecture is quite extensible, right? You can just bring other LLMs as well, not just Llama 2 or Streamlit here. So let me
Thank you so
stop.
much.
Yeah, and
Yeah,
I'll hand
thanks a
it
lot,
over to you.
Raghavendra.
Yeah, thank
Uh,
you.
Apologies everyone for changing the topics, but yeah, we have ChengCheng again on the call. And ChengCheng, over to you.
Yeah, I'm so sorry. My husband just switched the internet in our house, so do I not have video now? Okay.
Yeah, we can't see your video. Maybe you can try sharing your screen.
The screen sharing. Let's see. The video's not working. So imagine me being dynamic. I don't know. Hold on a second. Let me. Don't know what else I would need to do to turn the video back on, but I think. Oh,
Perfect. We see you.
I'm back. I think. Hold
Yeah.
on. Okay. Hold on a second. Sorry about that. Too much fun. Hold on a second. The video is kind of weird. Sorry. Okay. So I'm back. I don't know where I got lost, so I'll just continue on from Transformers. Did we get to that point? Hopefully. Okay.
Yeah, we can
Okay,
continue
so
from here.
Transformers, introduced by Google, 2017. And then if you've heard GPT, I'm sure everyone's heard of that. It stands for Generative Pre-trained, and the T is Transformers. So it's just another kind of neural network with a self-attention mechanism. And now the models can look at everything all at once. So long-term memory is not a problem anymore. And so it turns out that they're super data hungry, right? So you give it Wikipedia, piles of books, throw it the whole web, blogs, tweets, code, everything, right? So these models just kept improving. So another problem was the old models would process words sequentially, one word at a time. But the transformers could process things in parallel and just really take advantage of all that CPU power. So these models are now getting bigger, running faster, training on more data, and kept getting better. Okay, so you don't need to understand all the details here, but this is the transformer diagram, and Gemini sort of has an encoder on one side, a decoder on the other. And so a BERT model, it's little bit older. It only has the encoder side, which is it's good for simple predictive tasks like the classification or sentiment analysis. And then the GPT models and PaLM actually only have the decoder side, which is good for like the generative tasks. So the bigger models actually have the same architecture. If you can see, there's this NX that's sort of the number of blocks these can be stacked. So the original transformer only had 6 blocks. GPT-3 had 96 blocks. And GPT-4 and Gemini, we don't really know, but probably more than that, more than 96 at least. And then, so we've talked about language models, what makes them large. Size is measured in the number of parameters or neurons, right? So a large language model generally has at least 1 or 10 billion neurons. So it's not the same as a human neuron, but for reference, our brain has around like 85 to 100 billion neurons. And newer research shows that it's not just model size, but the amount and quality of the training data is important too. So it's like instead of having just a bigger brain, learning with a better teacher can help. So like a growth mindset, right? Okay, so in training, it's like a game. It can either be a fill in the blank or like guessing the next word. Like if you hear roses are red, the next word's probably violets are blue, right? Feels like a fancy autocomplete. But you can think about talking with someone who completes your sentences. It's like a sign of deep mutual understanding. But now I think the computer is doing that. And so part of what makes LLMs pretty exciting are these emergent abilities. Just by making the models larger, it actually picked up new skills, right? So this is from Google's PaLM 1 that was trained in 3 different sizes in 2022, right? So this is the smallest size with 8 billion parameters. So you can see it can understand language, answer some questions, and do arithmetic. But watch this. This is pretty cool. The medium size has 62 billion parameters. And so just by growing size alone, things got better. And it also learned to do translation, summarization, and other stuff. And then the large model at 540 billion parameters gained even more skills, right? Again, just by learning to predict this next word, it's able to do all of these tasks. I mean, in the past, we would have to train a separate model for each one, like to answer question, to code, or translate. So back to GPT, right? That P is pre-trained. What does that mean? So now LLMs, they're generalists, pre-trained to just understand human languages in general. And it kind of just naturally picks up all the other tasks. But these base models, they're huge. They cost millions to train and trained on tons of computers over months. But once the base model's been pre-trained, it's actually really fast and cheap to fine-tune it. So why would you still want to do that? Well, GPT-3 was released in 2020. And so ChatGPT was actually just a fine-tuned version of that. So why did it didn't go viral until like 3 years later? Why? It's actually this, the secret sauce is this RLHF, or reinforcement learning from human feedback. So you remember that next word prediction? I mean, it turns out to be great for learning language, but it's a little awkward to use. I mean, you don't go to ChatGPT and begin a sentence and expect it to, finish your sentence, right? So what you'll probably want it to do something or answer questions. But once it's been fine-tuned to follow instructions or, carry on conversations, it suddenly becomes super helpful and actually quite human. So I've kind of taken you through this whirlwind tour of NLP and LLM. So just to give you a bird's eye view of how all of this fits into the whole AI craze. From week 1, we saw that AI is actually this giant field within CS, right? So the goal is to create these intelligent machines that can perform tasks with human-like cognitive abilities. So we're trying to simulate reasoning, learning, problem solving. Then within that, ML is a subset of AI, right? And so instead of programming the rules, ML systems implicitly learn the rules and find patterns from the data. And so there are AIs that are not ML, and so these would often be considered like 𝗦𝗽𝗶𝗹, this good old-fashioned AI. It's like expert systems, and there's others that might feel a little old and neglected by now. And then within machine learning, there's another subset that uses neural networks, specifically those that have more than one hidden layer, right? So they're able to find even more complex patterns from huge amounts of data. So nowadays, a lot of people think like deep learning and AI are the same, but it's helpful to understand these distinctions. And so even within ML, there's plenty of algorithms that don't involve neural networks, right? There's decision trees, random forests, support vectors, machines, so a whole bunch of stuff. And then generative AI is yet another buzzword that kind of causes confusion. So it's actually an old idea, but the term itself became more popular recently. So it's essentially any AI that can generate complex output. Like text is what NLP focuses on, but it's not the only form. And, AI, you've heard, can generate images, videos, audio, music, and lots more. So even before ChatGPT, so RNNs, GRUs, LSTMs, those were also generative AI that's within deep learning. So they could generate text, but also sequences in general that were used for DNA or forecasting prices. And although transformers were invented for NLP, they're widely used for computer vision and other uses as well. And then before that, when we talked about the statistical models, like with n-grams and all that, those are like ML that don't use neural networks. And then finally, at the very beginning, I told you about linguists hand coding all of those grammar rules and vocabulary. So those are classic examples of good old-fashioned AI. So very famous examples are ELIZA or 𝗫𝗫, which is actually my graduate advisor's PhD project. So that is up to the NLP and LLM stuff. Use case, Word2Vec can be used to identify early warning signs in real-time typical. Yeah, I guess there's lots of other applications too. Okay, I think the rest are questions are not for me, so I am going to move on since I okay, since I lost a bit of time there. So hopefully you get a sense for how cool LLMs are. So let's kind of see how to build something. So the most exciting thing about Google's latest model, Gemini, is no longer limited to TextNet, right? It's now multimodal. It understands images and video. It's like it can see and hear the world. So to get started, we would go to AI Google Dev, which would look like this. I recommend you start off with AI Studio to play around and prototype. So you click on that nice big blue button. And here in AI Studio on the upper left, you would click on the Create API key. In the middle, you'll click to create the API key, lots of clicks there. So then a dialog will pop up for you to choose the Google Cloud project. Hopefully you've done enough labs to know how to do that by now. So one more click on that blue button and you'll get this long sequence. That's your API key. Treat it like a password. That will be your access to Gemini. Got someone else who also started off with 𝗦𝗽𝗶𝗹. Yay! Okay, so back to the navigation on the upper left, right under the API key button. If you click on Create New, you'll see some 3 types of prompts. There's also a prompt gallery further down, lots of examples to give you some inspiration. So let's play around a little bit. Okay, the freeform prompt is kind of the basic when working with a model. You can give it an input prompt and it generates the highlighted output below. And then you can use there's a button at the top that you can add an image. So here we're asking it to write a blog based on this photo. Then there's a structured prompt. It's kind of a similar idea, but it has this table interface using something called few-shot learning, where you give it a few examples of what you want. So this one generates marketing descriptions. At the top, you give it, some example images and a target audience with good descriptions based on the style that you want. And so you test it out at the bottom, give it the input and audience, then it'll generate the description at the highlight. And I realized I took the screenshot before it generated, but you would imagine when you generate, it would go where it's highlighted. So how does this help you build an app, right? So on the right, there's parameters these are the parameter settings for Gemini. So you can tweak the values just to see how the output changes. And at the very top right there, if you can click on Get Code, and it would actually pop up this dialog box with the code to call the Gemini API, right? So you can choose your programming language, run it in a Colab, or copy it to your favorite editor. So most of the parameters have default values that work fine, but understanding some more concepts can get you better results. So remember, I kind of talked about next word prediction. Actually, LLMs don't really use words. They use tokens, right? So they have a fixed vocabulary size around like 50,000 tokens or so. And in English, the common words are their own tokens, but longer or less common words are made out of multiple tokens. And tokenizers will convert the text into tokens. And so there's many different tokenizers. OpenAI has a tokenizer that's different from Google's. And then temperature kind of affects the idea of creativity. So if you remember, LLMs work with the statistics and probabilities as it's predicting the next token to see what's most probable, right? So if you set the temperature to 0, you'll get the most probable output, which is good for like factual answers that have right or wrong. But if you want a fun fictional story, then you can set the temperature higher to get something interesting, closer to 1.0 to get some creativity. Okay. And then the models, they come in 3 sizes. So why wouldn't you just use the biggest and bestest? Well, it costs more, might not run on smaller devices. So we'll be using the Pro model, which is available on the cloud. It's also a good balance between the capability and speed. And so then I'll always have to talk about safety. So every call to Gemini is automatically checked for these 4 categories: for harassment, hate speech, explicit and dangerous content. And so it gives you a probability rating for each of the categories. By default, anything with a medium or high chance of harmfulness is blocked, but you can adjust these based on your needs. Just be careful. And so if you remember, the goal of LLMs or NLP is to understand natural language, hopefully a little less of the unnatural computer languages. So we give them inputs as prompts, and they return that generated output. So prompt design and engineering become a whole field unto themselves. So the basic idea, though, is LLMs, they're not mind readers, at least not yet. So be clear and explicit in your instructions. Giving it some examples can help. So early models, they could only do math or translation after a few examples. That was called few-shot learning. But if it worked with only one example, then it's called one-shot learning. But many tasks nowadays, no examples are needed. So that's called zero-shot learning. But often, if you give it some examples, you can still get better results. And then telling it to think through things step by step, that actual keyword can also help. Remember, your math teacher, if they told you to show your work, it turns out when a model shows its work, it does better as well. Okay, these are the supported programming languages. The documentation on the website has plenty of examples. I'll briefly just walk through the quick start for Python. So you'll first install and import the client libraries, put in the API key that you got earlier, and you're actually ready for business. So your input if your input only contains text, you'll use the model Gemini Pro and call generate content with your prompt as a parameter. That's it. Few lines of code, and you're using Gemini. And if your prompt has an image, then you will use a different model. It's called Gemini Pro Vision, right? So then add your images to the prompt, and you can always go back to that AI studio that we saw, play with the GUI to see use the get code to see how the calls changes or how to call things. Okay, and then for a chatbot, you do need to keep track of this chat session. So the model, you think it's this, stateless living on the cloud. It has no idea who you are or your conversation. So you kind of need to send it the list of messages and let it know, hey, this is what we've been talking about, right? So the first 2 lines here sets up the conversation. And after that, you just keep on calling send messages. That continues the conversation. So it's essentially like generate content from before, but it'll remind the model of your conversation history. And again, a few lines of code, and this is the core of a chatbot. And then personally, I use vector embeddings quite a bit for both building applications, the RAG applications you saw, and also we use it in research as well to see what language models have actually learned. So calling the Gemini embed content, it returns this vector list of 764 numbers. It represents the meaning of the content. In this case, it's text, but eventually the content could include images, video, audio, and other modalities. Then there's a function you can call cosine similarity to compare and find related content. So that's things that have similar meanings. So this is super useful here. Task type is actually a new parameter for Gemini. Confess, I actually didn't see this until last night, but so I haven't had a chance to test it out thoroughly yet, but based on what I'm understanding it correctly, it could be pretty cool, especially for RAG applications, right? In the past, we would have to pick different embedding models that were optimized for different tasks, but now Gemini can allow us to specify the task type, so which lets the model know, are we trying to retrieve documents, answering questions, or do some kind of classifying or clustering? And so it'll return the embeddings that are more optimized for those tasks. Okay, and so that's kind of the basics to get started with Gemini. And again, the documentation has tons more details on using AI Studio, sample code to get started, and the free tier is very generous, so definitely go out, play with it, joining the bleeding edge there. Any questions that I need to address? Early in your presentation, you used the term Pong regarding use within large processes. Yeah, I'm not sure you heard me right because I don't remember saying Pong. AI Studio is not available in EU, UK, and Canada. Oh, bummers, I didn't know that. Let me dig into that. I hadn't realized that that was a limitation. I wonder if it's the, the EU VPN. That's a good suggestion. That I guess that's certainly one way to get around it. Is there anything else that I need to address at the moment before I move on to the? Actually, I'm not even the next section. I think I still have one more straggling slide in this section. Okay, now a quick detour from our detour. This is kind of unrelated to Gemini, but I wanted to take a step back and revisit just the concept of vector embeddings as numerical representation of things, right? So when it comes to recommendation systems, you can also use vector embeddings to represent movies, music, or whatever products that have certain features. So there's content-based systems, recommendation systems. They would recommend other products with similar embeddings or similar features embeddings. Or instead, you can have vector embeddings of the users based on what they like or bought. So collaborative filtering uses similar users and recommend their products. I mean, the idea is similar users have similar tastes, right? So there's a lot more details in your recommendation systems course. But I just know some people kind of find the idea of vector embeddings to be a little intimidating. So just think of it as a list of numbers which can be learned by the neural network, and it's kind of optimized to represent the features or qualities of something. Okay, Saw a little bit of movement. Is there anything I need to address? I think those I've seen before, or if I'm not understanding them, maybe we can go back at the tail end. Okay, so back to the official content review. So over the last few weeks, we've kind of been through the entire ML pipeline. Now we're kind of towards the end here. Things need to be deployed and running in production. So we'd like to automate that process and monitor it to make sure to keep everyone happy. So again, this is the pipeline you should know and love by now. Plumbing isn't the most exciting thing, but definitely important. So as your data flows through the pipeline, you start off by extracting, validating, preparing your data, get it ready to train your model. And after training, you'll still need to evaluate and validate the model. And even after it's been deployed, it still needs to be continuously monitored and kept updated. So how can we do all of this reliably? Right? If you're familiar with traditional software engineering, in DevOps, there's the concept of CI/CD. We'll need to take this a step further for MLOps. So continuous integration, you'll need to test and validate the data, schema, and models, make sure they still work. And if so, automatically deploy another model prediction service. So in the past, deployed to production, it might only happen 3 or 4 times a year, but now the goal is to keep things updated continuously. And then finally, continuous training is unique to MLOps. So model performance can drop over time due to things like feature drift or concept drift. So the model needs to be monitored and have automatic triggers to retrain and serve new models. So with any small changes, things should be automatically tested and deployed so everyone gets these fast and reliable updates. Okay, in the beginning, data scientists only had to worry about developing models using their little ML framework. But now with MLOps, you got to worry about all these other components like monitoring, serving, configuration, process management. So fortunately, TFX or TensorFlow Extended can help you. So TFX, it's a framework for building and managing scalable end-to-end production-grade ML pipelines, right? So the functional boxes here in the dark gray are implemented by TFX components. Specifically, the data analysis and validation functionality is implemented by TensorFlow Data Validation, known as TFDV, a bit of a mouthful. And likewise, data transformation is implemented by TensorFlow Transform, or TFT, which transforms the data to be the best input for your model. Then the trainer and hyperparameter tuning is done by Keras. Then model evaluation and validation is done by TensorFlow Model Analysis. And finally, serving the model is done by TensorFlow Serving. So each of those TFX libraries from the previous slide, below are all the TFX components that implements each of those functionality. And so here's the same components, but kind of arranged in the order that as the data travels down the pipeline from ingestion all the way to deployment. So on the exam, you'll need to be familiar with using these components. So make sure you pay attention to the details on the lab and the data manipulation components before the trainer. Those were actually covered very nicely in week 2 from feature engineering. So if you need a refresher, rewatch that recording on the YouTube channel. And so, but I would like to talk a little bit more about the serving. So here are different components involved in training. The saved model produces this result that can be used on different platforms, and you can export it to different formats. Like TensorFlow Serving is makes it available on the cloud. TensorFlow Lite is for Android or other edge devices. TF.js runs on the web using JavaScript, and there's also other language bindings too. So make sure you read up on those. And you'll also have options for deployment strategies that you need to understand. So we'll take a closer look at rolling updates, canary and blue-green deployments. So for a rolling update, you'll first try out a new version, slowly increasing in batches until they've replaced all the old version. So this allows it for some gradual deployment in a controlled monitoring way. And then canary deployment comes from a time when coal miners used to bring canaries into the mine. It sounds a little cute, but it's actually kind of sad. The birds were used as an early warning system. So, I mean, their tiny bodies were a lot more sensitive to the toxic gases. So if they stopped singing or just died, the miners knew it was time to skedaddle before the levels got fatal for humans. So in our case, a canary is a small test. And if that works out well, boom, it gets deployed everywhere. So the key is that they deploy to a small subset of users or servers first. Okay, and finally, for blue-green deployment, you'll need to maintain 2 separate environments. One is the original in production. The fact that I only have 2 blue circles instead of 3 like before doesn't mean anything, so don't worry about that. But then you'll set up another setting or staging environment, so both are running in parallel. And when you're confident everything works, then you switch all the traffic to the new version and then wind down the old version. So this allows you for fast switching and rollback if needed. And so that's what I've got. I think I'm ready for the questions, some sample questions, unless don't see new questions, I think. So feel free to drop your answers in the chat here. So this first one is, which of the following are benefits of running TFX on Google Cloud? Select all that apply, which is a little hint that there's maybe more than one correct answer here. So A is Vertex Pipeline is the only supported orchestrator for TFX pipelines. B, simplify scaling of TFX pipeline processes as your data grows. Automate your ML operational process for individual and multiple ML pipelines, and increase your pipeline development, experimentation, and velocity. So I see one brave soul. Monica thinks B and D are true. Then we see C and D are true. D, C, D, B, C, D. Anyone else? Is there anyone else out here? So I think most people seem to think D is true, and then B and C maybe. So, but nobody is picking A, which is actually a good sign. So B, C, and D are all true. So I think you guys all got bits and pieces of it. So TFX is known to be good for B massive data sets since it's built on Apache Beam. The C, it does automate the ML process. D, increases the speed of development. A, the key that makes it false is the word only. So pretty flexible. Besides Vertex AI pipelines, it does support other common orchestrators as well. So next one. In addition to, feel free to drop your answers in as I'm reading, if you're probably reading faster than me talking out loud here. So I'm killing time here. CI/CD practice in DevOps teams. MLOps introduces A, continuous classification, B, continuous regression, C, continuous training, and D, all of the above. D. Ooh, D. Got a lot of consensus here. More D. We got a C. One lonely C. Well, the lonely, a couple C's are coming in. So we saw that continuous training is unique to ML ops. And unfortunately, continuous classification and continuous regression. It sounds nice, but they're actually just made up nonsense words. So don't get fooled by this if this comes up on the test. They sound nice, but it really doesn't mean anything. It's inference, it's running inference, but it's not really a thing. So April Fools, I guess. Okay, so in what order are the following phases executed in a machine learning project? One, again, feel free to drop in your answers as we go along. Yeah, lots of faces, expressions here. So 1, selection of ML algorithm. 2, data exploration. 3, definition of business use case. 4, model monitoring. 5, model operationalization. Bit of a mouthful here. 6, model development. So I see some B. We got some consensus. Any dissenters? Got the bandwagon. Have we fooled everyone, or is this the right one? Yep, the phases of the ML project, super important to understand. Really happy to see everybody on board and in agreement here. So if you need a reminder of the steps, using the pipeline as a guide, that's helpful, right? You always start off by defining the business use case, then the data exploration. Once you have your data ready, you try some algorithms, then begin the model training and development, and then you operationalize the model to get the model deployed. And then even after it's out, you still need to keep on monitoring. And then I think this is my last question. We've got a couple minutes left. You want to have 2 versions of your application in production, but be able to direct a small percentage of traffic to the newer version as a gradual test. This is an example of which deployment strategy: canary chirp chirp, blue green, or the rolling updates. I see some A, C. Yeah, when I first read it, I can see why, and there's a B. Okay, so BB. Ooh, someone strongly believes in B there. Okay, so in this case, the answer is actually A. So the keyword is a small percentage of the traffic, which is associated with the canary development. So here's a quick summary of the different deployment strategies, right? So the canary is the one where it tests actually both rolling and canary does test a small subset. So the difference with rolling is it rolls, and so starts small, but it gradually does more and more. So it doesn't keep to just a small subset. So canary is the only one that starts off small. And the interesting about blue green, why it's not B, is because it never tests directs traffic to a small test. It tests like internally, and once it's known to work internally, it swaps all the deployment. The traffic goes, all it's like all or not, one or the other. So there's no gradual small test except for internally. It doesn't test in production. I hope that made sense. So that is actually all I have prepared. And yeah, sorry about the technical glitch. Got to keep your Saturday morning exciting, I guess. So I guess I have a couple of minutes, 1 little minute, I suppose, if there are other questions on any of the material here. Let's see if I'm missing any.
So we have a couple of questions.
Okay.
Yeah. Do you have an access of the Slido?
Yes. Hold on a second. Explain the answer to the first question again, please. Is that the first question?
That is the first question from the 4 that we saw in the slide.
The first question of the 4. Okay, let me see. Okay. So this one here, so which one? So A is not true because that Vertex Pipelines is not the only one. So which of the other three are you concerned is not true? So it's B, simplify scaling. It does simplify the scaling. That's why B is true, right? And C is true because it does automate the operational process. And then D, it does increase the velocity of your experimentation and development. So feel free to unmute yourself if I'm not, if you have access to your audio, if there's some part of your question that I'm not understanding.
Yeah, thank you so much, ChengCheng. Not everyone will have an access of their audio.
Okay.
But yeah, I can help you take another question.
Sure.
Yeah, the last one is off topic, time permitting. What features would you look for in Masters in AI program, especially on that is offered online?
Yeah, so in some ways, I'm probably not the right person to ask for this because I don't have a master's in AI, or the master's that I got in AI was so antiquated. It's decades ago. But I self-studied when I came back here. There's tons of great resources. I would say depends on what aspect of AI, right? If you want the ML stuff, there's a lot of traditional programs that teach you, but there's a lot of stuff that's just building AI, which I think there's a lot of potential there. So it really depends on what aspect. I would say most ML or AI master programs now they're pretty theoretical, on like the traditional ML deep learning programming type stuff, but there's a lot of other opportunities beyond that. And tell us more about the fairness and privacy. Oops. That moved. Fairness and privacy affected at scale. That I think I don't have time for this. Feel free to connect with me on that. That I think is a big topic that I probably can't cover in a couple minutes. I would say my focus is on AI safety as systems get larger and more powerful. So there's a ton of research on
Yeah,
that.
definitely. That's a broader question.
Yeah, that's probably
totally makes
a separate
sense.
talk that I
Yeah, definitely we can stay in touch, and if it's possible, we can organize another session for the folks.
Yeah, I can drop in my link. I think if people are access, I can give also. Oh, I might actually have my LinkedIn as the last slide. I can't remember. Woo! If people want to stay in touch. Is that there? There we go. Yeah. So, yeah, feel free to stay in touch if you have any questions. And yes, sorry about the technical issue. And yeah, and we're running a few minutes over, so I do want to be mindful of everyone's time.
Thank you so much, ChengCheng, for taking us through this. Yeah, it was pretty informative for us. Yeah, thanks a lot.
Oh, thank you for having me.
Okay. Would you mind stopping?
Yes.
Stop the sharing?
Definitely. Okay.
Yeah, thank you so much, ChengCheng. Let me share the screen again. Okay, so yeah, thank you so much, both the speakers. It was pretty useful to know all about it. So we have another session coming on April 6th, as I mentioned previously. And in that session, we are going to talk about ML ops and ML pipelines on GCP. So don't forget to RSVP and add it to your calendars. And yeah, thank you so much again. Just quickly, when we had initially, I mentioned about a surprise. So good news, we are offering exam vouchers to help you certify new acquired skills. However, just to make sure that everything is fair and good, we will distribute these limited vouchers effectively, and we have established a set of criteria that must be meet in order to eligible for the exam vouchers. So we will share more details on the Discord channel. So we would like for all of you to stay connected, and let me share the Discord channel link again. Okay, here is the Discord channel link. So yeah, we would share more details about the vouchers in the channel. And okay, let me see if we have anything else. Okay, we talked about the next session, that is on April 6th. So yeah, thank you all. Have a great weekend, and we'll see you on the April 6th session. Thank you.